Topic: mechanical energy. Mechanical energy can be classified into two: kinetic energy and potential energy. Work. Work is defined as force times distance. That's the product of the force and distance. That is, work can be done when the force applied causes the body to move toward the direction of the force, as expressed in the figure below. When a body is inclined at an angle theta, the force applied is given as work over cos theta times s. That means work will be equal to F cos theta times s. Question 1. A boy is dragging his toy car with a force of 20 Newton by the means of a rope. If the rope makes an angle 30 with the floor and the distance of 50 meters is covered by the toy, what is the work done by the boy? Solution. Work is equal to F cos theta times S. Work equals 20 cos 30 times 50 equals 866.02 joules. Conservation of mechanical energy. The law of conservation of mechanical energy states that energy can neither be created nor destroyed, but can be transformed from one form to another. That is, kinetic energy equals potential energy, which will give us half mv squared equals mgh, where m is the mass of the body, v is the velocity, g is the acceleration due to gravity, and height is the height attained by the object. Question. A stone of mass 60 kg is released from a catapult, and the stone fell through a height that is unknown. If it attains the final velocity of 2 meters per second, determine the height through which the stone falls. Take g at 10 meters per second squared. Solution. Since half mv squared equals mgh, when m cancels m, we have half times 2 squared equals 10h. Then h will give us 0.2 meters when cross multiplied. Machines. A machine is a device which allows a force or effort applied at one end or one point to overcome a resisting force, load, at another point. Mechanical advantage. Mechanical advantage is the ratio of the load to the effort, given as MA equals to L over E. It's also called the force ratio. Velocity ratio. Velocity ratio is defined as the distance moved by the effort over the distance moved by the load. Efficiency of a machine, EF, is equal to mechanical advantage over velocity ratio times 100 over 1. That is MA over VR times 100 over 1. In other words, efficiency is work output over work input times 100 over 1. Question. A machine is 40% efficient and it is used to lift a load of 20 Newton. What effort is used if the velocity ratio of the machine is 5? Solution. Efficiency is MA over VR times 100 over 1. 40 over 100 equals 20 over E over 5. We will cross multiply and divide both sides by the coefficient of E. Our E becomes 10 Newton. For a block and tackle system, the velocity ratio is defined as the number of pulleys. While for wheel and axle, the velocity ratio is given as big R over small r, where big R is the radius of the wheel and small r is the radius of the axle. Types of machines. The lever. The lever have the following parts. 1. The fulcrum or pivot. 2. An effort. And C. A load. Classes of levers. 1. First class lever or first order lever. In first order lever, the fulcrum is between the effort and the load, and the velocity ratio is greater than 1. Example of first order lever includes a pair of scissors, a crowbar, a claw hammer, and a plier. Second order lever. In second order lever, the mechanical advantage and velocity ratio are greater than 1, and the load is between the force and the effort. Example, a wheelbarrow and a nutcracker. Third order lever. In third order lever, the effort is between the force and the load, and the mechanical advantage and velocity ratio are less than 1. Example, the forearm, the forceps, and the tongs. The pulley system. The block and tackle system of pulleys. For a block and tackle system of pulleys, the velocity ratio is equal to the number of pulleys. Question 1. A block and tackle of 5 pulleys is used to lift a load of 50 Newton with an effort of 16 Newton is applied. Find the efficiency of the machine. Solution. Velocity ratio is 5, which is the number of pulleys. Efficiency equals MA over VR times 100 over 1. That is 50 over 16 over 5 times 100. When simplified, will give us 62.5%. The inclined plane. For an inclined plane inclined at an angle theta to the ground, the velocity ratio is given at 1 over sine theta. The wheel and axle. For wheel and axle, the velocity ratio VR is equal to distance moved by the effort over distance moved by the load. That is VR equals 2 pi r over 2 pi r. Why big R and small r represent the radius of the wheel and the radius of the what? Axle. That brings us to the end of the topic, mechanical energy.